Now, question is that why do you call it unit? We call it unit that it should be able to multiply. Because of that, unit is such a substance with whatever thing you multiply, you will get that same thing. Because of that, it is called unit. When you call it unit or unity, it means one. So now we use a unit. See, some of the units we have derived or achieved through our civilization. In our world, human habitation did not take place uniformly throughout the world. It has occurred in some scattered places. And interestingly, those places were very far away from each other. There's no connectivity. Only in some selective places the human habitation has taken place. Initially, human beings were in a nomadic conditions. They used to move from one place to another in search of food. So in the search of food, when they moved, they never remained static in one place, because when the people started moving from group, this obviously after some time there will be scarcity of food in this way. Why? Because they never used to grow anything. Whatever was available in the vicinity of that area, especially in forest, whether it is of plant source or animal source, it is to deplete gradually, and the time after some time it was almost scanty or not available. So they move from one place to another. But mind it, when they moved from one place to another, they had a feeling how much distance they have covered. So different places, different ways were there to measure the distance. Okay. So some of this unit we derived from our prehistoric time. So there cannot be any scientific definition for it. Okay. So this type of units we call it as fundamental units. See, anything which does not have any logic, we call them as fundamental. We have found that we have become a victim. We have become a victim of this fundamentalism throughout the world. And it is especially presently throughout the world we are suffering because of the religious fundamentalism. Whatever they say, you have to obey. But if you ask them that why do you say like this, what is the reason behind that, they will say no, you have to obey it. Just like that we are being told in our childhood that sun rises in the east. If you get up early in the morning, have you ever seen in the sky it is written east? Never. If in the evening the sun sets in the west, but there also it's not written there. So people have decided we call this as east, with the direction in which the sun rises we will call it east, and the direction in which we will set we will call it west. Okay. So these terms are fundamental. So altogether there are 7 fundamental units are there. 7 fundamental units. By this time all of you know it. We have fundamental units. And second one we call it, this is already studied in lower classes, derived units. So there are 7 fundamental units are there. You know all of them. But suppose someone asks you that, can you tell me now? It will take little bit time from you, because all of you don't know all of them, but you have to search in your memory. You will say one length, then you say time, then you say temperature. Okay, three things are very, very frequent to us. Other thing, mass. That fourth one is also very common to us. Other three things may not be common to us. Okay, so let me write a spelling. This spelling is wrong, but we'll try to find out the 7 units from there. If you feel that it is better for you to remember, you can use this one. And if you feel that you have found a better one, you tell me, I should try to follow that. In science, there cannot be any question that he knows everything. No. Everyone can find an easier way. I have written a spelling which is wrong. We know the spelling of metal is METAL. So let us add some fun in it. Say you have found, suppose you have bought a red skirt. There can be different shades of red. But if it is very bright red, and if you want to express to your friend how red it is, what you do? You generally stretch the word. Is it not? When you stretch the word, then you know the gravity is more. So here also I have stretched the word. Think that is very hard metal. Okay? So let me write now here. So this stands for mass. How do you express it? You express it as gram or kilogram. Okay? This stands for electricity. Electricity. How do you express it? You express it ampere. This is, say it is temperature. How do you express it? Either you express in the form of centigrade, or you'll find all throughout we are going to use another scale which is called Kelvin. Now, this is time. How do you express it? You express it as second. So this is, we call it amount of substance. How do you express it? MOLE. M is small. Okay, either we write MOLE or it is being made in short as MOL. Now, what is this? This is length. How do you express this one? Either in centimeter or in meter. Then what is this? This is for light, how bright it is. How do you express it? You express it as candela. CD. Please write it. Moment you finish writing, please tell me. Huh? Written. Hello, can you hear me?
Yes, sir.
Finished?
Yes,
Is it
sir.
visible to you?
Yes, sir.
Okay. Once I rub now, this mark remains. So I don't know what to do. Anyway, okay. Now we'll go for derived units. See, derived units are obtained from fundamental units. Fundamental units. Like say we have density. What is density? It is mass by volume. What is volume? Volume is length, breadth, and height. Length, breadth, and height all are being measured in the form of what? Centimeter or meter. Is it not? So let me write here now. Let me write here as okay, mass we express in gram, and this is centimeter cube. Or you can express them as kg. If you use kg, then you have to use there as meter cube. So generally you'll find we write it in this way. This, or we write it as kg meter cube. All right. Now, what is velocity? Is a rate of displacement. Is moment some rate is comes, then comes a time. So what should I write now here? Displacement by time. So if you measure in centimeter, it can be centimeter by second, or we can write it as centimeter this, or we can measure in meter, okay, and second. So it can be meter second inverse. Now what is acceleration? Is the rate of change of velocity. So it is rate of change of velocity. Okay. So now moment the rate is there is what? Change of velocity by time. So now we know that it is, say it is meter this. We have just now we have written this by this. So it is what? This. So we have used all the scale that you think that that was there in our in our fundamental units. So most of the units that you are going to come across there, these are all derived units. These are all derived units. But all of them are nothing but the combination of fundamental units. Now, after measurement, you have to express in digits. Okay? But when this measurement you will do, you either these measurements, whatever you have going to do, maybe that same work was being done earlier by someone. So in that case, you want to find out whatever that you have got, is it correct? So in that case, you have a result to compare with the earlier result. Suppose you are trying for any learning how to cook. So right from childhood, your mother has made it for you, or maybe your father has made it for you. So you have that taste in your tongue. So after, if you have made that food, then you after eating, then you may find that it is not as tasty as your mother made. So you want to repeat again. Or maybe that it is a dish which nobody have made till now. You thought that let me go for it. So once you have made it, you tasted, because this taste earlier and you never had. So you want to find out whether the way you have cooked was correct or not. The next day again you do it. You may find the next day's one is better than the previous one. Then again you try to repeat it. Same thing is done in our scientific experiments. And in that case, we will come across two terms. We call it accuracy and precision. When you go for accuracy, means already the result is there in your hand. You repeat it, so not repeat. You do it and compare with the previous one. If you find is almost same, then you are happy. And if you find a lot of difference is there between you and the earlier result, then you say that there's something wrong which I have done. That is, you will say it is not accurate, or you will call it inaccurate. And you, when you introspect, then you try to find out your fault. And that is nothing but when you express, when you try to find your fault, that is your, when you find it percentage, and that is your error. Okay. So now, what is accuracy? Accuracy determines how close is the result. Sorry, not result. How close is the measured value? To the real or correct value. Not let me write correct, let me write true. So this is the accuracy. So this is already, this work is being done by someone else and you are trying to do it again. This is the thing that you do generally in your laboratory experiment. You will be doing physics experiment, you will be doing chemistry experiment. So the value, true value will be with your sir. He will not tell you, or he might tell you. He will tell, when you do it, he'll tell you, no, no, you see, your your result is not correct because it is a lot of differences between the true value and your value. Okay, so that difference is called error. And precision is the one that you have done first by yourself. But before you present it to others, obviously, you don't want to get embarrassed. Suppose you have done it once and you want to show it to the public, then when you explain them everything, when you did, you find a lot of differences there. So unnecessarily you'll be embarrassed. So you will repeat it again and again. And when you find the results are very close to each other, then your result will be considered as true value for your future generations. So precision is the degree of agreement of the same quantity So let us be very, very clear about these two words, accuracy and precision. Accuracy is the when you compare your result with the previous reported one, and precision is the one which you have done by yourself, is the original work, and you try to repeat it again and again to see that whether it is close to your own readings are very close to each other or not. Okay, now you have to write down your result. It will come in some digit. So how you are going to write it? So you cannot write as you wish. Okay. For that you have to follow a tradition. Okay. So this is called, the way you write it is called scientific notation. In scientific notations, all the numbers, large or small, are expressed as numbers between multiplied or divided by 10. That is, a number is generally expressed in the form of n into 10 to the power n, where n is called the digit and 10 to the power n is called exponential. Like, for example, 138.42 is written as 1.3842 into 10 to the power 2, or 0.00138.42. So forget about this. Is written as 1.38 into 10 to the power minus 3. Okay, so now you have written all this result. Now we comes here, significant figure. That also you have studied in school. So what is significant figure? A significant figure includes all those digits that are known with certainty, plus one more which is uncertain or doubtful. I'll tell you. Very simple thing that you have done also. Okay. Say in your house, someone is suffering from fever and you have taken a mercury thermometer. Say in the thermometer you have found, you have told it is 102.3. But these graduations are so small, sometimes it's difficult for us to see even with the naked eye. Then your mother may say 102 point what? She will say 3. I think it is not 3. It is lying between 3 and 4. Then this. Then you hand over to your sister or your brother. He will say, hey, it's not 102 point. It's 104 also. You can't see it properly. So what did you say here? 102.4. Then looking at this, your mother, she told, no, let me see. She will say it is not 103 and 4. It is 105. 102.5. So what is changing? See, these are fixed. These are all with certainty. Which is uncertain? The last digit is not certain. So these are called. So it has all the fixed figures or certain figures with one which is bound to change. Why? Because if you again record the temperature for him or her, you may find no, it is not 102. Sorry, it is not 102.3. In fact, 102.4. Again, you check, you may again will be 102.3. So what is changing? This is the one. So these are all certain figures, and this is the one which is uncertain or doubtful. All right. So these are the stories of the significant figures. Now, you want to find out which is significant and which is some rules are there for determination of significant figures. See, in any digit, if the numbers are vary from 1 to 9, all of them are significant. That is 100, 2, 3, 4. How many significant figures? 4. Now, if a 0 lies between two non-zero figures, then this is also 4. This is also 4. All right. All integers are significant. If a 0 appears in between integers, this is also significant. So here it is also 4. 4 significant figure. Here is also 4 significant figure. Now, if a 0 follows the integers, in that case, they are also significant. Say it is 1.0, 1.00. So these are also significant. In this case, it has 5 significant figures. But if a 0 precedes the digits, then these are not significant. Suppose I have written here now 0.01200. Sorry, say 1, 2, 3. In that case, you have to forget about this and this. Okay, so how many significant figure it has? 3. Now, if I write them in scientific notation, I can write 1.23 into 10 to the power minus 2. In this case, significant figure is 3. And if you wish, this exponential part also can be taken, or exponential part can be ignored. So here, let us ignore it. We'll write it like this. One digit you have already read in your book is the Avogadro's number, 6.023 into 10 to the power 23. Just now I told you that zeros after the significant, integers is also significant. Here we have written 5. So if you wish, if you write it, someone writes like this, you can say, what is the significant figure? Say 1, 2, 3, 4. 4 plus 23 is what? 27. So say if someone writes it is 27 significant figure, he is correct. And if someone writes it is 4, that is also correct. So this is the way we find out the significant figures. Okay. Now, if I go for addition of significant figures, if I add it, how much it comes? 8, 5, 2, and what? It is 2. What did I get here? So in this case, it should be expressed in the minimum significant figure. See here, what is significant figure here? Here also it is 4 and here is also 4. So it is correct. But if it is like this, 1.2.4 and this is, if I write here, 1.2. So it comes to 6, 4, 2, 1. Okay. Who is having the minimum significant figure here? 1.2. So you are supposed to write the result as 1. It is, what is the significant figure here? 12. Same is the case for subtraction. But if you multiply this, the significant figure expressed with the minimum decimal. So in that case, it will come in the minimum decimal that you have to express. In multiplication and division, you will find is given in the form of minimum decimal. So I'm not going further because it is already you have done in school. So today I finish here. So tomorrow we'll meet again at 3:30. I know that some of you are having problem with the physics tuition at 4 o'clock, but I'm little helpless because 5 o'clock I have class with class 12. All right. So in that case, and moreover, I cannot prepone it to 3 o'clock. Why? Because if I prepone it to 3 o'clock, then I will be able to teach you only for 1 hour. Not only that, and also if your school starts, you you will have problem this time. So let's see. All right. So all the best, and I told you that in that group I'll post you my account number. Thank you. All the best.
Thank you, sir. Bye.
Bye.
Thank you, sir.
Welcome.
Thank you, sir.
Welcome.